If we want to convert 10 into BCD, then the 1 will be converted into 0001, that is the first one, and the second one will be 0 will be of 0000, 4 zeros. So this is how we will be converting our BCD. So I will show one more example. If I have to convert the value 15 into BCD, if I want to convert the value 15 into BCD, then I have to write the value of 1 in BCD is 0001. Similarly, the value of 5 in BCD is 0101. So this is the value of 5 and this is the value of 1. Hence, it is 15. This is one of the very big advantage of BCD, that the conversion can be done very easily, right? So this is about BCD. Now let's go to the simple addition operation that we are doing in BCD. So BCD addition is almost similar to that of our binary addition, but there are some simple changes. That simple changes comes because of the number of bits difference that we have. Let's see in detail. So I am going for addition operation, where I am going to perform addition of 5 and 4. So if I am going to write it, so it is going to be 0101 for 5. Similarly, for 4 it is going to be 0110. The output what I am going to get is 1001, which is the 4-bit number which is present in BCD, and it is legal, right? If it is not present, then we have to treat it as illegal. Let's go for the second example. In this example, I am going for 6 and 4 addition. If we perform 6 and 4 addition, obviously the output will be 11. So for 11, the output what we should have in BCD should be 0001 and 0001. Let's see how we are achieving this. So now I have, this is going to be, yes, 000, yes. So now 6 is going to be 0110. Similarly for 5, it is going to be 0101. So if I add this, I am getting this number, which is 11 in decimal, but it is not illegal, it is not available in BCD. As it is not available, I am just going to use the word illegal, so it is not available. So in these kind of cases, what I should do is that I have to add binary number 6 to it. Binary number 6110. I have to add 6110. The reason why I am adding 6110 to this is already said. I am also repeating it again, as in our decimal we have from 0 to 15, which is of 16 numbers, which is of 16 count. Whereas in BCD we have from 0 to 9, which is of 10 counts, and the remaining what we have is 6. That is the difference what we have. In order to substitute that, we are using that difference. So now what I'm going to use the same number 0111 this number. I have taken this number here and to this slide. So now I am going to add 6 to it. This is nothing but 6 I have added. So by adding 6, the output what I'll have is 1. 1 plus 1 is going to be 0. 1 is there. So 1 plus 1 is going to be 0 again. Again 1 plus 1 is going to be 0. I am getting a carry. So I am just appending this 4 zeros because that is not going to do any change. So I am just going to append this 3 zeros. So by this I am getting 0001, which is nothing but 1. Similarly 0001 is nothing but 1. Hence I have converted my illegal code into a BCD code by adding 6 to it. This is how we will perform the BCD addition. Let's go for one more example of BCD addition. This is example where we don't have any of the illegal codes. So if we see in this, once again, I'll just correct my mouse. So if we see in this 25 plus 13, conversion of this is very easy. 5 is going to be 0101 and 2 is going to be 0010. Similarly, this is done. Just we are going to add it. We are not having any illegal code. That is 130, that is 8 is present in BCD. Similarly, so we don't have to do any correction. So now I am going for the next case. In next case, I am going to go for this value. In this value, I am having 679.6. Similarly, this value is added. So I have used this one This is the first one for 6. This is for 8, for 9, 6. Likewise, I have converted. As the BCD conversion is very easy, I have directly done that. Now I am going to add these both value. If I add these both value, I am getting an illegal code. This is an illegal code, which is 1110. Again, this is an illegal code. Again, this is an illegal. When any illegal code is encountered, obviously I have to add 0110 to it. So as shown, I have added 0110 to it. Once this is done, I'll be getting the answer. I should not take my carry to this step. While doing this, obviously we'll be taking the carry and we will be adding here. In this, we should not do it. We should propagate the carry to the next step. Right. So by doing this, same thing I have done. I have just added this carry. That's all. Right. I have shown you separately. That is the difference. Right. So now what happened is that 0, 0, the same thing added with 1. This carry which is going to propagate. Similarly, the carry of this is propagated. Similarly, the carry of this is propagated. Same operation as we all do, right? Usual binary addition only. So I am going to get the exact, see, this is going to be 4, this is going to be 6 by adding this, and this is going to be 1, which is nothing but the BCD equivalent of this value. This is how we will be doing this. Hopefully everybody understood this one. The same operation is done for BCD subtraction also. The same correction will be done in case of with 6, same operation will be taken care. Right? Only difference is that in the previous case we did addition, here we will be doing the subtraction. That is about your BCD addition and subtraction. Now let me go for gray code, which we have already discussed about the gray code. Now let me talk few words about how to convert this binary into gray. So how we will be converting an binary element into gray code element. So now I am going to have this value, that is 1001 I have. So I have to convert this into gray. So what I'll do is that I'll directly drop my first element. So first element is directly dropped. So that is 1. The next step what I will do is that I'll XOR this value with this value. I'll be XORing first element with the second element, and that output will be given. So remember, in XOR, if we have different output, obviously the output will be 1. If you check here, this is 1, this is 0, then obviously this is going to be 1. Now again, I am going to check this one and this one now. I am going to XOR this one and this one as both are same element. So this is going to be 0. Similarly, now I'll be XORing this one and this one. So as this is different element, I'll be having 1. This is how we will convert a binary number into BCD number. Now I'll go for the example of converting gray code into binary. Now let's see how gray code is converted. The number what I'm going to take is 1001. Similarly, usually as we did, so 1 is going to come here. Now what we are going to do is that this output is being XORed with this first value. Here we did with the elements only. Here the output is going to get XORed. That is the difference. So if I XOR, I am going to get the different element. So I am getting 1. Now this output has to be XORed with this element. Now this output will be XORed with this element. So I am getting 1. Here 1 and 1. 1 and 1 has to be XORed. So I will be getting 0 here. Same element. So I will be getting 0. This is how we will convert gray to binary and binary to gray. Right? This is the logic diagram for binary to gray code conversion. This is the logic diagram for gray to binary conversion. This logic diagram can be obtained by using the truth table of this all possible combination for 4-bit. From that to truth table, we will be performing the reduction by using K-map. From that K-map, we will be forming this diagram, forming this logic diagram. So this is about gray to binary and binary to gray. Now let's see about ASCII. ASCII is the American Standard Code for Information Interchange. This is used for character encoding in electronic communication. All communication, transmission, everything we do, that the characters are being transmitted by using this value only. Right? Then this is used for representing the text in a computer. This is used for representing text in computer, right, in telecommunication equipments, etc. This is of 7-bit code. ASCII is a 7-bit code and it has 32 control codes in it. First will be 32 control codes, then rest will be of the representation. That is all printable characters, non-printable printable characters, and the numbers is from 0 to 9, then alphabets and punctuation, etc. Everything will be coming in this ASCII code. Now we are going for next parity code. Parity code is nothing but this is used for error detection. The main purpose of this parity code is for error detection. So let's see what is parity. So now in this parity, we will be adding one more extra bit to the element. Let me start from the beginning. So in my transmitter, say for example, I am going to have 4-bit, that is 0, 0, 1, 0. If I am going to have 4-bit, I will be adding one more extra bit in the LSB or in the MSB, and I'll be sending this. I'll be transmitting this. Say I'll be transmitting this extra bit. With this extra bit, I will be transmitting this. And now in the receiver section, in my receiver section, it will be receiving this value 0, 0, 1, 1. This value it will be receiving. By looking at the type of parity encode, this will identify whether the received signal is right or wrong. So this is the explanation about the parity encoding and decoding. Right, now let's go for this. So there are two types of parity encoding available, that is even parity encoder and odd parity encoder. Right, so let's see this with an example. So if it is going to be even parity example, now I am going for a 4-bit. So now I will be having 0, 0, 1, 0. Now if it is even parity, and other one if it is odd parity. So if it is even parity, I will be putting 1 to it, so that making sure that even number of ones, that is count the number of 1 in the binary. If the binary 1 is even, then the parity is even. So now if you look at this, right, I will be, as this is 1, so it is odd. So in order to make it as even, I have added one more 1 to it, so that now it is having 2 ones, it is even parity. Similarly, if I am going for odd parity generation, then 0, 0, 1, 0, I will make sure that it is in odd only. So now let's go for this example of 8-bit, where I am having 0, 1, 0, 1, 1, 0, 1, 1. That is, I am having 1, 2, 3, 4, 5 ones. So in even parity, I should make sure that I have even number of ones. So I am adding 1 to it. So my even parity bit will be 1 here. Similarly, the same case, if I am going for odd parity, I will be giving 0, so that it will be in odd. So hope you all understood. I will go with one more example of this even parity, odd parity in this case, that is even parity, odd parity, that is 0, 1, 1, 0. So if I am going for even parity, so I'll be counting the number of ones in this case, right? 1, 1. So it is even number of 1. So I'll be giving the even parity value to be 0. Right? Similarly, if I go for odd parity, then obviously what I'll do, I'll make sure the odd number of 1 is odd. So obviously I'll give 1, so that while transmitting, it will be 0, 1, 1, 0, 0. This will be transmitted. If the same case for my odd parity, it will be transmitted as 0, 1, 1, 0, 1. So look at this. This will be transmitted. Hope you all understood. So this is one more example. Now my sender is going to have 1, 0, 0, 1, 1, 0. This is what I have. So now I am going to use even parity. So I will add one more bit to it. So I have added one more bit, 1, 0, 1, 1, 0, 1. This is the parity bit I have added, and then I have transmitted. So in the receiving section, I will be receiving this bit. In this receiving bit, I will be having the parity checker. Parity checker will check. If it is even parity checker, it will make sure that the number of ones that is present is even. If it is same, then it will be accepted. If it is not so, I have shown an example with error here. See, the first bit has got changed. So if you look here, as this is even parity checker, it will be looking, but when you look at this, the number of bit is going to be in odd. So obviously it will reject it and it will ask for retransmission. It will ask for retransmission. This is about parity encoder, how the even parity is done, odd parity is done, how the parity is checked, right? This parity can check only one bit change and this can only detect, right? There are some codes which can detect and also which can able to correct it.